So exponential decay, main difference between the two is your b value is going to be a fractional amount. So when you go to graph these, the same rules apply as they did last time. You have y equals 3 times quantity 1/4 to the x. Grab a couple, start something around. Grab a couple of sheets. So when you go to graph these, remember, just like we had with exponential growth, identify your A, your B, any H's or K's. What's your value of A here? 3. What's your value of B? 1/4. Is there a shift? No. So it's H's and K's are zeros. So what you wind up doing is that your parent function, since there's no shift, is this. So it's 3. So you graph that in your calculator. 3 parentheses 1/4 to the x. I just quickly put it as 0.25 because it's quicker to type sometimes in the calculator. And then graph it. You get an idea of what it's going to look like. Now, just like when you had growth functions, your A is always your y-intercept. Still happens here. So we just go to our table and we start plotting some points. And that's really all there is to this, guys. You plot your points, just like we did before. Slowly but surely get up there. Y-intercept is at, my y-intercept is at 3. At -1, it's 12, so it's already up off the graph. And then at 2, or at +1, it's 3/4. So you get the idea. It's going to look like this. Okay. Yes. In your y values and stuff?
Yeah.
You get to change the node.
No, that's what you put it in.
Oh. I'll look at it. I'll figure it out.
Maybe because you put it in as a decimal.
Oh.
If you put it in.
Oh, if you put it in as a decimal, it'll come out as a decimal. If you put it in as a fraction, it'll come out as a fraction.
It's like within the one word, right?
Yeah. In my calculator, it's different than how the operating system like that. That's why. Okay. So that's basically it. Now, when you go to your H's and K's with these things, do you think anything's going to change? No. Your H and K values still hold true. You still have, you still plot your parent function. You plot that first, then you shift it. Do you remember where your horizontal asymptote is going to be? At K, very good. Your horizontal asymptote is at K. So these graphs are going to be identical to what you guys did with the growths. There's nothing that's changed. Absolutely nothing's changed. So we look at this. Y equals -3 times 1/2 to the x plus 2 all plus 1.
So the only thing that changes is that B is fractional.
Yeah, these are fractional amount between 0 and 1. That's the only thing that's changed here, guys. So as we go to plot this out, we still label your A, your H, and your K, and B. What's A in this case? -3, B, 1/2. What's H? -2, and K is 1. It's x minus h. Every time you have h in the case, it's always it's usually a minus an h value, so it's always opposite sign. Okay. So that means this graph from the parent function is going to go what direction?
No. Okay.
Well, you said every other direction, so which way is it going? Left. It's going to go left 2 and up 1.
Good try.
Okay? Remember, H, horizontal, left and right. K, vertical, up and down. So your parent function, put this into your calculator to get your generic points. So let's see, -3 to the 1/2 times 1/2 to the x. Oops. And it's okay. So now we have your, when we have this, then go to your table. And once you get into the table from there, you're just able to plot some points off your table and then shift everything. So here, once again, I'm going to just kind of slide this over so it's on here. At -2, it's at -12, it's down here. -1, -6, 0, -3, -1, or 1, -1.5, 2, 3/4. So here is my invariant function. Now with each of those points, I move it to the left 2 and up 1. Left 2, up 1. Left 2, up 1. Left 2, up 1. Bless you. And we have a new asymptote at y equals 1. That's the k value. So this curve is approaching 1. There you go. So it looks identical to what we did the other day. Bless you. Just go in the other direction. And from the sound of things, graphing these for you guys was pretty easy. I don't think it was too difficult. Oh, don't forget, we will quiz out of this stuff on Thursday, 8-1 through 8-3. Okay. We'll quiz out on Thursday. Okay, so because we get into E tomorrow, it usually takes a little bit more time. What's that? Oh yeah, you got 4 days, man. You got plenty of time. You'll find out tomorrow.
Water.
Comes after D, before F.
What's that? I don't know.
So, just like you had growth models, we'll have decay models. Now, what happens here, it's the same idea when we had those growth models where you had 1 plus your rate. The only thing that changes is now 1 minus your rate. So you still have your A is your initial amount. Your R is your percent as a decimal. And T is generally years. So what happens here is you talk about what's called depreciation. I know you guys have all heard that before, right? Cars depreciate, things like that. So what happens here is that you're going to be given a percentage. Let's say your percentage was 9% for a depreciation of 9%, and your initial amount was 1,000. So you bought a really cheap car, and it depreciates at 9% a year. So holding its value, I guess. Be 1 minus 0.09 to the T. So if your initial amount was 1,000, your rate is at 9%, but the book will write it like this. Just like, remember how yesterday the book was writing it as 1.102 from, what was it, number 54, I think we were talking about? Same idea. They're just combining it right away. So you're going to see it in these model functions like this. They're relatively easy to work with. It just takes a minute or two to fill in the blanks. All right? Once again, if you're in econ, you probably have used this by now, or you will. It's pretty easy to work with. Here's an example. Car. You're buying a car for 24 grand. It's not bad. I don't think you're really buying very many new cars nowadays for 24 grand, to tell you the truth. I think the average price is about 30 nowadays. The car is increasing in value by 16% a year. Right next to the potential decay model for the value of the car use the model to estimate the value after 2 years. So when you go to write out the model, you have to identify what your initial amount is. So your initial amount is 24 grand. Your rate is 16%. So what is 16% as a decimal? And then your T would be your, whatever, your years. So the model, they're asking you to write out the actual model. 24 grand times 1 minus 0.16 to the T. Yeah.
What's the 1 in front of 0.16?
That's the growth rate. Oh, I'm sorry, the decay rate. Remember how yesterday we had growth rate was 1 plus the rate?
That's always going to be 1.
Yeah. And if it's growth, you're adding, if it's decay or depreciation, it's subtracting. Okay. So here, then you go one step further, you get 24 grand times 0.8, so I know how to subtract, 84 to the T. And then it said estimate how much it's worth after 2, so what are you going to substitute in for T? Okay. I'm not going to make you graph that. That's just kind of silly. Why? You have a graphic calculator. There's no need to plot out 24,000 on your graph paper. But I would use the graph to estimate when the car has a value of 12 grand. How would you do that? Yeah. Go to your table. Do me a favor real quick. I want to see what you guys come up with. Put your function, put your depreciation function in your table, and figure out how many years it takes for the car to be worth about 12 grand. Yeah. Yeah, that T value, sometimes it's just think of it as your value of X. I just left this T because that's your time. You guys getting between 3 and 4? Now, here's the thing. It's not always going to tell you an exact value. You know, in 4 years, it's going to be worth 12 grand. So, like she said, between 3 and 4 years, that would be an okay answer. You can't say 4 years because it's worth less than 4 years, and you can't say 3 years because it's worth more. You got to say between 3 and 4. Does that make sense? Yes, no, maybe so. Like I said, growth and decay, they're usually pretty simple to work with. There's not a lot going on here. So why don't you go ahead and figure out how much your stereo is worth. Write out the equation. You buy a stereo system for $780. Rocking it old school. Each year, T, the value of the stereo system decreases by 5%. Write out the model. What does it look like, guys?
780 times 20 times
To the T. Good, yeah. I'm glad you changed that up. So you got your amount is going to equal 780 times 0.95 to the T. Do we agree? Questions? I gotta run downstairs, so I wanted to get through that a little bit quicker.